Hi everybody and welcome back. We're looking at example 2, still on page 67 of the workbook here. And this is going to be our first example of actually calculating a change of coordinate matrix. Okay, so they'd like us to, for example 1, calculate the matrix that changes beta prime coordinates to beta coordinates. So let's start by reminding ourselves what beta and beta prime were in example 1. Okay, so recall that beta was the basis 1, -1, and 1, 1. I'm just looking back to example 1 and recopying that. Okay, and beta was just the standard basis. 1, 0, and 0, 1. Okay, and the change of coordinate matrix, that was the formula that we wrote down in theorem 2.22. I'm going to remind you of what that is by writing it in the margin here. So Q is computed by finding the matrix of the identity transformation taking us from beta prime coordinates to beta coordinates. That's what we need to calculate. Okay, so we're going to do that, excuse me, in the same way that we did that back, I believe it was in section 2.2 where we started talking about matrices of linear transformations. So we're going to start with the basis beta prime, substitute those vectors one by one into our transformation, which is the identity transformation. So we'd start with IV of the first beta prime vector, which looks like 1, -1. Okay, and then we do the same with the second one. Okay, well, what happens when you substitute a vector into the identity transformation? Well, it stays the same. So IV of 1, -1 is still 1, -1. And IV of 1, 1 is still 1, 1. And then we want to write those outputs as a linear combination of the basis beta. Okay, so we would like to fill in the blanks. Something times our first beta vector plus something times our second beta vector, and do the same thing down here. Okay, well, here's where it's kind of nice because beta is the standard basis, so it's pretty easy to fill in the blanks in this case. We're just going to get 1 and -1 there, and 1 and 1 here. Okay, and then recall how we actually form the matrix. Okay, so basically those two coefficients are going to become the first column of our matrix. Okay, and then second two coefficients there and there are going to become the second column. We're just following the same process that we learned to write down the matrix. Okay, so Q is this matrix. All right, now that's our answer. So we're actually done with the problem, but I'd like to talk a little bit about the significance of the calculation that we've done here. Okay, 2 points that I'd like to make. First, is there a way that we could have shortened this process? If you think about it, we didn't really need to write these two things because we know what's going to happen when we apply the identity transformation. We're just going to get the same vector back again. So if you wanted to shorten this calculation, you could just start with the two vectors here and here, which happen to be the two vectors in beta, and just write those as a linear combination of the vectors in the other basis. That will always work when you're calculating this change of coordinate matrix. Okay, second point that I want to make is, could we check this? Check that this is really the matrix that does what we want it to do. Okay, well, let's do a couple of sample calculations here. So I'm going to start by, actually, let's give ourselves a little bit more space here. Start by writing down the matrix that we have. Okay, and I'm just going to pick a vector, 1, 2. It might seem to you that I'm picking it out of the air, but actually I'm choosing that vector because it was one of the vectors that was on our table in example 1. What happens when we do that matrix multiplication? Well, let's see, if we focus on the first row, 1, 1, and multiply that by 1, 2, we're going to get 1 times 1 plus 1 times 2 is 3. And then focus on the second row, -1 times 1 plus 1 times 2, that's going to give us 1. And if this is the correct matrix, what should be true is that we can think of the 1, 2 there as being beta prime coordinates, and the 3, 1 as being beta coordinates. Okay, because after all, this matrix is supposed to be the change of coordinate matrix that changes beta prime coordinates to beta coordinates. Okay, let's look back at the table in example 1 and see if we can confirm that calculation that we did. Okay, so I'm going to scroll back on you here. Okay, so remember those two vectors, 1, 2, and 3, 1. And notice right here, we started with 1, 2, those were our beta prime coordinates, and we ended up with 3, 1, those were our beta coordinates. So that first column in our table confirms the calculation that we just did. Okay, right here. All right, let's try that with one more. Okay, so if we take 1, 1, negative 1, 1, and multiply it by negative 1, negative 1, which also happens to be a vector that was in our table. Okay, do that matrix multiplication. Let's see, if we do that, we're going to get 1 times negative 1 plus 1 times negative 1, that's negative 2 up here. Then looking at the second row, negative 1 times negative 1 plus 1 times negative 1, that gives us a 0. And again, that should be taking us from beta prime coordinates to beta coordinates. And if you scroll back, there they are. Negative 1, those are beta prime coordinates, and negative 2, 0, those were beta coordinates. Okay, so we could look at the two calculations that we just did and just make the comment here that this agrees with our calculations from example 1. Okay, so really all that this matrix is doing then, it's just kind of a gateway. It's taking us from one set of coordinates to another set of coordinates.